Hi everyone, this is 11.5 part A of measures of center, variation, and the normal distribution. So measures of central tendency, that is just a value that describes the center or middle of data. Describes middle of data. And when we are talking about mean, we use this symbol, mu, to represent it. It's kind of like a U with a very long front part, beginning part. So the mean you should probably be familiar with is the average value, while the median is the middle value. And the mode or modes is the most repeated value. So we're going to look at finding the mean, median, and mode of data sets. And the easiest way to do this is definitely to put your data set in order from smallest to largest value. So I'd want to start with 35, 46, 51, 51, 53, 58, another 58, 59, and 60. Now that it's all in order, this will make finding the mode and the median way easier. So the mean is just going to be the average value, so you're going to sum all of your data points together and divide by the number of data points there were. So if I add all of these together, mean or mu is equal to 471 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of data, and that will get me about 5.2 repeating as my mean. The median is the middle value, so I want to find the most middle value, so I'm just going to cross them out from outside in until I get the middle value, 53. And the mode is going to be the most repeated value. There could be more than one, and for this problem, you can see that 51 is in here twice, and so is 58. Those are the most repeated values, so 51 and 58 are the modes for this set of data. Make sure you pause the video and try the next one on your own. I'd love to see your work when you turn it in, but after you can check your work with my answers. So measures of variation, that's next. Measures of variation is a value that describes how spread out a set of data is. So measures of dispersion. The mean absolute deviation is the average, a distance of each value to the mean. So in order to find this, the mean absolute deviation value, the MAD, you need to have the mean for your data set. So let's start there. The mean, when I add all these up, should be 479 divided by 5. Oh, did I mess something up? Oh, divided by 6, sorry. Divided by 6 is 79.83. So, to find the mean absolute deviation, you are finding the average distance of each value to this mean value. And so what we're going to have to do is, what this means is the sum of all of the values when you subtract it from the mean, right? And when we sum that all up, the absolute value divided by the number of terms we had will get us this MAD value. So I'm going to be subtracting each of these values from the mean, and you want the absolute value that you're going to be adding together, so that's going to be 5.17 plus 5.83, 8.17, 0.17, 12.17, and 19.83. So all of those divided by 6, that's going to give me the MAD value. So I'm going to do that up here. That's 51.34 divided by 6, which is about 8.56. Again, so what I did was I subtracted, I did 85 minus 79.83 to get 517, and then these values, like 74 minus 79.83, that was negative 5.83, but I'm using the absolute value, so you're always going to be adding the positive values of these, of the difference. Again, remember to pause the video so you can try number 4, and you should get 2.6. The next thing we're going to look at is variation. Variation is the average squared distance of each value to the mean, and the standard deviation is the square root of the variance. The standard deviation is probably the most useful measure of dispersion, meaning you use standard deviation a lot to figure out how close together or spread apart the values are. So what do the numbers mean? A low standard deviation indicates that the values are closer together. I can fit that here. And a higher standard deviation value indicates that the values are more spread apart or spread out. So If we look at the formula above, again, this is the symbol indicating sum. So we're summing all of the values in the data set when we subtract it from the mean and square it. We're going to sum all of those and then divide by the number of terms we had. And for the standard deviation, you're doing that, but we're going to be square rooting it. So again, you want to find your mean first. So when we add these all together and divide by 5, because n equals 5 here, we're going to get 92. And now solving for the variance, which is sigma, this symbol is called sigma squared. That's going to be 85 minus 92 squared plus 88 minus 92 quantity squared plus 91 minus 92 squared, 96, and 100. So all of that is being divided by n, which is 5. And when I simplify, I get -7 squared, -4, -1, 4, and 8. Again, all of that is still divided by 5. Calculate that out. Make sure you square all of these before you add them together. And you should get 29.2. Then to find the standard deviation, you just square root it. Since variance is sigma squared, standard deviation is just sigma. We'll get 5.4. So there is a shortcut to do this, and that is by using your calculator. The TI-84 is what I would recommend for this. The calculator steps are listed here. You want to start by hitting stat on your calculator, and that is the button right here under the delete button. You're going to then go to L1 and enter all of your data values. After you do that, hit stat again, but you're going to move over to calc this time, and we want to use one variable stats. So once you choose that, you hit enter. You can scroll down to find sigma and sigma squared, which will be your standard deviation and your variance. So if you do that for number 6, you'll get 23.62 for variance and 4.86 for standard deviation. Make sure you do this for a couple of problems. That way you are sure that you know how to use the calculator to find this. Don't just rely on my answers. Make sure you are able to get this as well. Okay, stay tuned for part 2.